Yes.
Okay, so we had some camera difficulties. I'm gonna stitch them together afterwards and then submit it. But back into it, we were doing gold plating. Precious metals plating was pretty predominant, and we started getting more industrialized over the next 100 years. They started doing, in Russia, religious icons plated in gold, crosses, Catholic symbols, and different things. It was pretty interesting to know that we did it over 200 years ago, and that we've been pretty much doing it ever since. We started moving into more modern technologies over time. They started doing like old car bumpers around the turn of the 19th century, just different things like that. And they started experimenting with new metals other than gold and silver. They started doing copper and different things. So I'm going to talk a little bit about the chemistry now. So it's basically just an electric source connected on one end to an electrode and the piece of metal that you want to plate. And then there's dissolved metals in the solution. It passes the current over and it basically strips some metal off the first electrode, passes through the solution, and then deposits onto the piece that you want plated. It gives you a nice coating that you couldn't do by hand or by dipping it in molten metal, because it wouldn't stick very well. It'd kind of just be like a cast. But this is pretty much not chemically bonded, but very, very tight bonding. Talked about how they started doing larger batches. We've kind of evolved into what's called rack or barrel plating over time. We do have these huge racks at my work, big as this room, that they put parts on. They dip them into each tank. Each tank's like 1,000 gallons. One of them 6,000 gallons. It gets pretty large scale. Some of the modern examples would be gym equipment. Tons of car stuff is done. A lot of car stuff has to be corrosion resistant. Airplane parts, almost every airplane part is electroplated and then coated with paints and other things. Pretty much every hardware like screws, screwdrivers, nails, anything is coated in something, because these different coatings provide a lot of corrosion resistance. They give a nice, less abrasive finish. They can be more lubricated. They can survive a lot longer throughout different lifespans. There's different categories to it. Most severe being like fully outside, submerged in water, compared to in your bedroom where there's almost no humidity in there. Different metals, different things, different thicknesses. They can all be used and be manipulated to get exactly what you want. My job does zinc coating. We do zinc, and then we do what's called a chromium passivation on top, where you take the zinc plating and you dip it into a chromium solution, and it turns the top layer of the zinc into chromium, which is even stronger. And with that, you can get some cool colors. You get blacks, yellows, clear blues that look like a really nice stainless steel. You can get more glossy, more matte, different things like that. We personally do a couple gym equipment things. One of the major brands of gym equipment come through us, made right in Ohio, shipped out, and sold for a ton of money, and they look beautiful. Car parts, I know Honda goes through us sometimes. Hyundai goes through us a little bit. We do quite a bit for them. Not like a ton of different parts, but a lot of smaller parts for them. Like there's a spare tire thing that we'd use. The little screw, it's through us. We do that. There's definitely some limitations to electroplating compared to other things, such as galvanizing, dipping. That's a whole nother topic for a whole nother day. One of the main issues, especially in modern day, is that plastics are not very commonly electroplated. They can be, but you have to have a very specific setup to do it, and it's very finicky. Not all metals behave the same. Like, I couldn't walk into a copper plating facility and do it correctly. It'd be completely different chemistry, same fundamentals, but very different. And each factory has different specializations. You can go for what metal you want. Do you want zinc? Do you want copper? Do you want chromium? Do you want gold? Do you want silver? Then you have to go through, how do you want it plated? Do you want to do a cyanide, which is what we do, the most dangerous of them? Do you want to do a more basic solution, a more acidic solution? And then you even go into what color do you want it? Some factories don't do certain colors. We do a couple, but some only run one. You get some finicky chemistries, like I said, and each one has its own challenges and hurdles. You can have completely different outputs running the same line. one block over if they're in different factories, just depending on how the tanks are kept. One major thing is waste. We generate a lot of waste, and we go through huge extents to try and make sure that our wastewater is clean and ready for treatment at the city plant. Our major concern is chromium, a little bit of zinc, and cyanide. Cyanide's a deadly poison that can pretty much kill you on contact. So you have to make sure it is completely clear of the water. We run it through basically a whole water treatment plant. We have half our factories dedicated to water treatment. We run that, check that. I do a lot of that, is checking that and making sure it's all good. Replacing pumps, adding chemicals every single day just to neutralize the solutions. A lot of other factories get other heavy metals, like I said, chromium, zinc, iron waste, silver waste. Silver's pretty toxic. A fun fact about it is that electroplating was actually one of the first forms of waste treatment. They are not forms of waste treatment, but one of the first regulated forms of waste treatment. The EPA came down on us first. We were one of the first industries to get hit with, oh, you can't do that. You need to fix that. People are dying. People are getting cancer. And it's true. That was through Frank Altmaier with the NASF and the AASF. It's pretty interesting going through a lot of that stuff. We do have a couple other major sources. We have Britannica talking about how the chemicals work. That's where I got all that from. But a lot of that knowledge is my own. We do have some electrochemical engineering sources as well in there. So it's not all just my brain, but a lot of it is through other places. Do you guys have any questions about any of the electroplating?
Wow.
So what are the you say you do a lot of gym equipment?
Yeah.
Like what kind of gym equipment do you do?
Barbells. We do a lot of barbells. I don't really want to mention the brand, but
Sure. Don't mention the brand.
the beautiful blacks come out, and when I see them in a gym, I can tell exactly that we did it or we didn't do it. But it's pretty interesting.
So are you like talking about the dumbbells or the plates or everything?
We've done all of it.
Oh, okay.
The ones we're currently doing are the long barbells for like bench pressing, squats,
Oh, so
and deadlifts.
the actual barbells themselves, the bars.
Yeah, yeah.
Oh.
Yeah, it's pretty interesting.
Oh, that is really cool, actually, yeah. Huh.
But I run all the chemistry. I make sure all the chemistry is correct. I have to make sure pHs are correct, concentrations are correct. If they have issues with parts coming out bad colors, bad plating thicknesses, they come to me. I mess with that. I have a little thing called what's called a Hull cell plating solution, and I can run a very small part, and I can check all of the different color scales and different densities of metals. I can check all that and see exactly what I need to do, and I can refer to my manuals, refer to that, see how we're running. I can go from personal experience, say, hey, we should try this, and I feed that to them. They take it from my little 1/10 of a liter tank, scale it up to 1,000 gallons.
Wow.
Yeah, I do a little bit of math in there to throw that on. There's a lot of electrochemical math to do this kind of thing. I only have a 2-year degree from Stark State for chemistry, but I am working on my bachelor's of biochemistry, and I hope to kind of incorporate some of my plating, toxins, and waste treatment into my work. I've been doing that currently. I work with a lot of analytical instruments. My favorite is the atomic absorption, which tests different metal concentrations in solutions. So I could take your blood, find out how much iron's in it. I could spit it through a flame, and it'll read exactly what your iron content is.
That's interesting.
Different things, I can test different metals. I can test exactly what's in it. If I've got an idea, I can run it through that, figure it out.
Awesome. Very good.
Nice.
Perfect.